So let's start somewhere.
Sure.
So can you paint me a picture of the last 15,000 years?
The way I would start would be, why is this significant to the world? And this sort of question is really significant. And that is that Native Americans, and we'll call first Americans as a way to sort of distinguish sort of later Inuit, Yupik, sometimes people refer to these, Paleo-Eskimo populations. That's a much later Holocene expansion, so maybe 5,000 years ago. We see that group enter in the far north, and they pretty much stay in the far north. When I say first Americans, I mean every other Native American, everybody was a single population at one point. They're all related, and they're related specifically to a group that we call East Asians. So they're a subset of East Asians that we begin to see the divergence around 36,000 years ago. And this would have taken place somewhere in Asia, somewhere in East Asia. The earliest individuals we have, like Tianyuan individual, like the Amur River 33,000 individual, is around 40 to 30,000 years ago. We actually see where they're at, and they appear to be in sort of northeast China, in that basic area, in Siberia, China. And so we see the emergence of a subset, a group sort of diverging from the other East Asians, and these would be, Han Chinese would be the descendants of some of the East Asians now. And so this group we term the first Americans. And this was this individual group, and they finally split off, and they stopped exchanging genes around 26,000, 25,000 years ago. The next item that we see is an admixture event. And they're admixing with a very unique population. We call these ancient North Eurasians. So it's a population that doesn't exist now as a distinct group. Obviously, we have descendants. And this was a group that seemed to have connections with Europe, certainly connections with Asia, but all of the individuals that we know of now are around Lake Baikal. So this would be southern Siberia in modern Russia. And that also gives us an idea of where probably the first Americans were between around 24,000 and around 20,000 years ago. So in the US, archaeology is a sub-branch or subdiscipline of anthropology. And of course, anthropologists are working with living populations. And so there's sometimes a disconnect between the geneticists who are thinking of a population, a specimen, an individual. Well, these are people. They're doing things on the landscape. They're just like you and I. The brain's exactly the same. And the thoughts, the wishes, the needs, the interactions, the social interactions that people have with the family, with the kin group, the larger population they're with, and neighbors, right? Exchange, information exchange. All of these sort of issues are on the ground what we're interested in. We're interested in life ways. We're interested in culture. And so sometimes there's an issue with, okay, admixture. Well, what does that mean exactly? So what are we talking about? What are the possibilities? And so as a small example, there's this idea of a divergence of NNA and SNA, North and South Native American. And the geneticists are okay with, there's a split. There's a divergence. No discussion of why, how.
Oh, yeah.
And so one of our contributions, I think last year or the year before, was that we're thinking about how could this happen? And one possibility is that you have a number of different routes as alternatives when you're coming into Beringia. And the coastal route is one that has very unique characteristics. The interior route is another with different characteristics. And if you have a single population that begins moving along these different routes, now you've got a barrier mechanism, Cordillera ice sheets, which acts to separate. And that could be an explanation for this observed genetic difference, but in terms that are meaningful, that this reflects behaviors and choices by people at a certain time period that lead to consequences genetically later on. The fact that this is a successful migration, that this leads to the peopling of two continents. It's amazing. It's successful. And just as a as a way to sort of frame this, the level of sophistication of the technology is almost sort of unbelievable to like an average American, in a city nowadays, where you imagine being dropped off in a helicopter into the Brooks Range in January. You're going to die. It's just going to happen, right? You're not going to survive. But looking at the sophistication in the clothing, the tailored clothing, which we know is a part of this, we've got bone needles that are coming out at very early sites. Some of the figurines that we see in Siberia with the parka sort of material, the way in which you would tailor clothing to survive in the conditions we have here, the knowledge to schedule your resource collection seasonally so that you're taking advantage of all of the natural resources as they change and fluctuate, and you're predicting, right? You're making life predictable like we all want to do. That's an amazing phenomenon. That's never farther from my mind. I always want that to be sort of a guiding principle. And when we interpret new finds, when we interpret new genetic data, it still has to make sense to people. The difficulty, even in recent past, when we work with modern Native American peoples in the region, it's difficult to live in a boreal forest, right? The carrying capacity is very low compared to a temperate forest, or even deserts. So to understand the traditional ecological knowledge that makes that possible, it's a big deal, right? And it connects that we're doing in the ancient past with what people are still doing today in a meaningful way. And so as a small example, the work we've done on early salmon fishing, salmon is like a incredibly important resource now. It has political significance now. There's, subsistence issues that relate to state management and even federal management that, this is important to people. And we're happy to work collaboratively to understand the traditional knowledge, to understand the longevity, the conservatism, the implications of these sorts of behaviors on the landscape. So that's how I frame it when I think about this.
Yeah, well, I was going to read you something that my partner said. And my partner, Patrick Anderson, is Tlingit. And he wrote something I found really interesting. And I was wondering if you had a brief comment. He said, if we have a future,
it's connected to our knowledge of the past. So the validation of that knowledge is real important. The big story for us is how we can utilize that knowledge that we developed with our genetic adaptation.
With the place that we're at.
Yes, that's great. I agree with everything that he said. And I think he highlights a couple of important issues. One, the last thing you said, the place-based. And I think as scientists, there's this emerging understanding that native knowledge is intimately and intrinsically connected to place in a way that, a visiting researcher that comes in for the summer and counts fish cannot imagine. They can't appreciate. And so I think that element is critical. And I encourage, even as much possible collaboration as there can be to set out what are the relationships, what is this indigenous knowledge that can help manage resources for the future for their people, their descendants, and the world as a whole, because it's not an issue in my mind as a scientist of history alone, because history is not the past, remote, sort of not connected. It is always happening. Yesterday was history, right? And it sets the framework for today and for the future. So, these issues of understanding relationships of people to animal resources or plant resources or the landscape, it's a big deal. And it has to be a part of anthropology, archaeology, any science that's moving forward to help collaboratively address issues of interest to people now. And there are a couple of ways that we could think about this in terms of real life. One is climate change. And we're undergoing climate change now. This is not debated in the scientific community, and it's particularly exacerbated in the far north. So in the Arctic, we're seeing even more climate-related event mechanisms that are changing the landscape in living memory. A good example would be watching moose expand into areas that they haven't expanded to, or willow, shrubby growth that's expanding north. And understanding how the system actually works is a big deal now, and in particular, how did it change in the past? And so the story that we've talked about with first Americans coming into Thuringia and into North America, this is in the context of climate change. And it was another warming event. In fact, it was the last major warming event for now. We're moving out of the last ice age into really warm and more moist conditions. And so understanding baseline, we're always really interested in baseline. So for instance, one of the things we did when we looked at paleo diet, we had two individuals, two babies from the Upward Sun River, and we wanted to understand what was the diet of the mothers, 12,500 or 11,000 years ago. And one of the things that we needed to do was understand the baseline ecology. So we can take examples of salmon or caribou or moose now, and we can look at their stable isotopes, as a way to reconstruct diet and how they fit into a food web. That's not 10,000 years ago or 11,000 years ago. So we began to collect samples of the animals, build a baseline food web to put the humans in. And from that, we understood that fully 30% of the diet, the protein diet of those two mothers at the end of the last ice age was coming from salmon. So this turns on its head the idea of these are just mammoth hunters with, that they're not connected. They're a separate reality than modern indigenous people. And that's not the case at all. It's the opposite, that they're utilizing resources that modern people are still utilizing in the region now. And in fact, the actual distribution of terrestrial mammals to salmon, it's pretty equivalent to what modern non-Dene peoples are in the region now, their subsistence diet. That's pretty compelling. And then understanding these transitions as they occur through time and how people adapted to them, in my mind, helps everybody. It helps the modern subsistence issues. These are not short-term managers. These are people that have lived with fluctuating caribou population, for instance. We know that caribou are susceptible to crashes. It behooves us to understand when did they crash before, what were the consequences, etc.
Can you describe what we would have seen in Shuka Kaa's world, or let's say Tree Cat Island? And I'm thinking specifically of, okay, you've got the glacial maximum, you've got all that water tied up, and then and the sea levels are lower, and then it begins to melt and the sea levels rise, which inundated villages along the California coast here. And one of the questions they have with the Chumash Marine Heritage Site, where are our villages and where did we live? And it's like, well, 13 miles offshore, maybe, so what was going on there, and what can we expect, if the Greenland ice sheet melts? And we look at the past and we say, well, apparently it melted pretty fast. It was like 500 years or something, right?
Welcome to Shuka Kaa's world, a realm of water and ice, lasting home to the remains of a young man found in a cave, dated to 10,300 years ago, and found to be genetically related to all Native Americans, from Canada to the tip of South America.
So I think I'll start the answer with an area of active erosion. And it's not just sea level rise that can do this, the increased storminess. And that's, storminess is a factor, a variable that we want to look at through time. Fire regime is another one. When do we see different fire regimes? In the interior, at least, it looks like some major changes were happening around 6,000 years ago. But now we have the issue like Shishmaref, a number of coastal Inuit villages that are in danger. We've got houses that are falling into the sea. Actively right now, it's a big issue. Same thing with some of the interior rivers, like Fort Yukon in Alaska, more kinds of erosional events. So it's not nearly just sea level, but lots of climate factors can impact sort of settlements and the dangers that people face. So with the Northwest coast, The way I would frame it is you certainly have the coldest, driest conditions around 25 to 18,000 years ago. So this is before people were coming into that area. So this would be the time period where you have the lowest sea levels and the most amount of ice. Story of people sort of coming into that region, they would have been in a very dynamic environment, very changed environment. Because for one reason, the deglaciation was not like a gentle curve. There were blips, and we can track this with like Greenland ice core, where we can look at sort of temperatures through time. So there were stadials, which were cold periods, and interstadial, which were warm periods within this deglaciation. And so the Bowling Allerwood probably is when you had people coming in for the first time. And this is a period between, 14.9 and around 12.9 or so. Warmer conditions, moisture conditions. And it seems like this could have been the push that allowed for this expansion. It got cold and dry quickly after around 12.9. We don't yet know to the extent that it affected humans, but there does seem to be some changes in culture. The Clovis morphs into like Folsom, other, smaller groups that this could be an effect of the climate change. We don't know. And then at the end of the Younger Dryas, that's basically the end of the Pleistocene around 11,600 years ago. That's when you see sort of a very rapid warming. And it's almost like, the warming was very rapid. It reached a peak quite early on. We call this the Holocene thermal maximum, so the warmest, moistest period. And it's sort of transgressive across the globe. It didn't happen exactly at the same time. But in our region, in the far north, it happened pretty early on. So probably very early in the Holocene. So around the time Shuka Kaa would have been in that cave or nearby, would have been a relatively warm climate during this deglaciation process. And so in terms of sea levels and sort of coastlines, it's also really complex. It's not a simple one curve. You have to establish sea level curves for each region. You have global sea level rise, that's one thing, but you also have what we call isostatic rebound. So you've had glaciers depressing the crust. As they're melting, you have that rising. You also have sea levels rising. They don't rise at the same rate.
Right.
And so there are a number of different local curves. We don't have precise data on everything, but what it suggests is that in some areas like Haida Gwaii, you have all of those earlier coastlines gone. They're simply not available. They're underwater. In other areas like more near Haines, for instance, you have actually quite a bit of what would have been the coastline 14,000 years ago. Now that's above sea level now. So it all depends on the region that you're in. Imagine very dynamic. There was probably seasonal sea ice to some extent. Certainly, we know there are plenty of animals from those cave sites. We know there were bear, a variety of other herbivores and resources. And there's no reason to think that the fish weren't there early on as well. So if you ever take the trip from Valdez to Whittier, you're going to see ice going to the coast. I mean, it's just like a very not pleasant to make a life there. Same thing with some of the Aleutians until the recent past, where we have evidence of people there at least 8,000 years ago, 9,000 years ago, but not much before then. So it does seem like, that early coastal group would have been interior adapted people that came to this new area and liked it and were able to adapt and they stayed put and developed into the peoples that we see today. So I think of all the regions where you can make that claim, where, the argument of, we've done this technology or we've utilized resources in this way, it's strongest in the Northwest coast because of that genetic continuity that we can demonstrate. So it makes it very exciting to look at sort of, management strategies and, the way Native peoples use traditional knowledge to have a successful life way for millennia. We imagine agribusiness as like a culmination of the best way to live. I mean, the fact of the matter, that's what people think. The state level societies that we enjoy are based essentially on a very few numbers of, grains, right? Rice, maize, wheat. And that's a unique phenomenon. You know, the world hasn't really done that. It's an experiment. We don't know how sustainable this is in the long term. As archaeologists, we have this broad framework. We can look back. Yeah, that's pretty unique. It happened in an area of the world that seemed to be more marginal, right? It didn't occur in Japan. It didn't occur in the Northwest coast. It didn't occur in northern, sort of the Baltic Sea in Europe. Areas where there was high productivity and what we term sort of Mesolithic lifeway, so broad spectrum foraging was people were very well adapted and they had large populations early on. That's not where farming got started. Farming got started where they couldn't do that. They were in an area of more arid conditions, had population pressure, this rain that responded well to disturbed areas, which humans are going to do. They're going to, you know, have disturbances. Grass goes in pretty quickly. It was a, you know, very specific thing, right? So what we can learn from Native peoples now is, what does true sustainability look like? What does a lifeway that can handle major climate changes, extinction events, you know, changes in vegetation, but yet sustain themselves? So this is not I don't think this is a historical question that's interest only to descendants. This is a question that's relevant to everybody on the planet. You know, for what are the options for humans to do things, and what are the consequences?